Hello, this is Miss Moore, and today during chemistry we're going to discuss measurements. Today's essential question: what is the importance of accuracy and precision in scientific measurements? As a quick warning, today's lecture is full of a bunch of terminology, all of which you need to be familiar with. All right, let's do this. We'll start with qualitative versus quantitative measurements. So what is a qualitative measurement? Qualitative measurements are descriptive, okay? So they don't have any numbers. You're just describing the thing. You could say things like for mass, instead of saying it weighs 2 pounds or something, you could say it was light or heavy. For volume, instead of saying something is 30 milliliters, we could say it's small or large. For temperature, hot or cold. So those are qualitative measurements. We're describing the quality. Okay? A problem with qualitative measurements is that they are subject to personal bias or opinion. What I think is very heavy, someone else might think is not so heavy, maybe light. If I think something is very small or somewhat small, somebody else might call that large. What I think is hot, somebody else may think as warm. So qualitative measurements, it's very difficult for everyone to agree on this description because it's subject to personal bias. And that brings us to quantitative measurements. Think of quantitative as the word quantity, where qualitative, you think more of the quality. It's a descriptive term. Okay, quantitative measurements. Quantitative measurements are more definite, and they usually involve numbers and units, and we'll talk about units in a little bit. Okay, standard units are needed to go along with the numbers for a more accurate description. For example, if I said something had a mass of 2, is that 2 grams, 2 ounces, 2 pounds, 2 kilograms? It really matters. Okay, so standard units are things like grams or inches, miles, degrees Celsius, whatever. Okay, so, and they're important so we can understand what that number means. If I say, for example, I live 50 from school, what are you thinking? Well, are you thinking, wow, she lives 50 miles from school, she has a far commute. Conversely, what I really meant is I live 50 yards from school. I live right across the street or something. Okay, so you need, when we're talking about something, a quantitative measurement, we need to use units. Quantities and units. A quantity is something that has magnitude and size. A quantity is the thing that you're measuring. And that could be the volume, the mass, the distance. Those are all quantities. A unit, on the other hand, is the standard used to measure the quantity. It is how you measured it, what you measured it with. For example, did you measure distance in inches, feet, or miles? Did you measure mass in ounces, pounds, or kilograms? Okay, these are units, where volume, mass, and distance are quantities. So quantity is the number. You can think of the quantity as the number. So let's put that in here. That'd be like the number. And the unit is what goes with the number: inches, feet, miles, ounces, pounds, kilograms, etc. Standard international units. SI units, or which stands for Standard International. So the SI base units are a subset of the metric system, and they are used as the standard system of measurement unit in science. And it's important for us to have standard units, so that way when I'm reading a scientific discovery from somebody I can understand the measurements. Okay? So the SI base units features 7 different units. We're only going to discuss some of them. By the way, because the SI base units are a subset of the metric system, we will be using the metric system this year. Okay. So here are the SI units that we're going to be using. Okay, so we have the unit meter is used for the quantity length. We use the unit kilogram for the quantity of mass. The unit second is used for the quantity of time. The unit Kelvin is used for the quantity temperature. And the unit of moles is used for the quantity of amount. Okay. For now, I need you to be familiar with what unit goes with what quantity. And you're going to become more and more familiar with these as the year progresses. On to accuracy and precision. Measurements are an important part in the discovery of new information, and that's what science is. Measurements must be both correct and reproducible to be good science. Reproducible means I can make the same measurement multiple times, and somebody else could make my measurement as well. Accuracy. Accuracy is a measure of how close a measurement comes to the actual or true value of whatever is measured. Okay, so how close am I to exactly how much something weighs, or exactly its size, or its distance? Okay, an accurate measurement is what we call a correct measurement. A single measurement can be accurate, meaning it is very, very close to the actual measurement, the actual quantity, or it can be inaccurate, meaning not very close at all. To evaluate the accuracy of a measurement, it must be compared to a standard or a known measurement. So again, accuracy is how close a measurement is to the actual quantity, the actual real measurement. Precision is a measure of how close a series of measurements are to one another. A precise measurement is a reproducible measurement. All scientific measurements should be repeated several times. That is important. In labs, you should be repeating your measurements several times. A precise measure will be one in which the results are the same or nearly the same each time it is tested. Okay, so for example, if I were to weigh something and I put it on the balance and it weighs 3.1 grams. If I weigh it again and it weighs 3.1 grams, and then I weigh it again and it weighs 3.15 grams, and I weigh it again and it weighs 3.09 grams, that is a fairly precise measurements, right? We got a series of measurements, all of which are very close. Versus if I were to weigh something and I got 3 grams the first time, and then the second time I weighed it, I got 4.7 grams. And the third time I weighed it, I got 2.4 grams. Those measurements are not very precise. Okay, so precise measurements, a series of measurements measuring the same thing again and again, you get the same or almost the same quantity. Okay? To evaluate the precision of a measurement, you must compare values of 2 or more repeated measurements, okay, which is very different than accuracy. You can have an accurate measurement, meaning being very close to the actual measurement, with only a single measurement. Error. In science, as in daily life, there will be error in measurements. Okay, so two terms we need to talk about, we need to know, I guess, to be able to talk about error is experimental value and accepted value. The experimental value is the measured value obtained in the lab. It's what, if I was doing an experiment, it's what I found out, what I saw, what I measured. Versus the accepted value is the correct value based on a reliable reference. Okay, so again, experimental value is what the experimenter found out. The accepted value is basically the right answer. Think of it that way. Error is the difference between the experimental value, what the experimenter discovered, and the expected or accepted value. Okay, the right answer. So error is the experimental value minus the accepted value. You should know this. Error equals the experimental value minus the expected value. Error can be either a positive or negative number depending on whether the experimental value is greater than or less than the expected value. Percent error. Percent error is the absolute value, meaning just the quantity, not the sign, no positive or negative, of the error divided by the accepted value, then multiplied by 100 to get a percent value. Okay, so you can see what percent off you are. What percent error do you have? So, another formula you should know. Percent error equals the absolute value of the error, which is from this formula here, divided by the accepted value times 100. And again, absolute value means just the number no sign, meaning no positive or negative sign. Okay? Percent error, I guess I should get rid of this arrow here. Percent error will always be a positive number. And that's it for today. Have a good one.